Okay, so far we've graphed ordered pairs. Like if they give us a set of ordered pairs, we've put them on our graphing coordinates. And yesterday we started even graphing functions. Usually when we're talking about packages of things, like there are 4 balloons in a package of balloons. How many packages are there in, or how many balloons are there in 1 package, 2 packages, or 3 packages? But today we're going to start by just graphing equations. So maybe the equation will say, I'm going to start with one that says y equals 3x. Okay? And the step I'm going to do first is I'm going to make a function table. Okay, that's what you're going to have to do when you're solving your problems. Step 1 is make a function table with 10 entries. Okay, so now I'm going to use, when I make my function table, I'm going to use my pencil just so it's a little easier and not as crowded. My equation is y equals 3x. I put my x on this side, I put my y on this side, and how many spaces do I need to make? How many numbers am I going to put? 10. Which one number should I start with? The easiest number of all to start with. Natalie Arm. No, look at numbers. What number am I going to start with? Dominic.
1.
Even easier than 1.
0.
0. I'm going to go 0, then 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, and then 9. Okay, those are going to be my 10 numbers and my 10 entries in my function table, or my function table. And guess what? I can fill this half of it out without even doing any math. 0 through 9. Boom. Now, what do I have to do to get my y's, though? I don't have my y's yet. Justin, what do I have to do?
You have to count by 2.
No.
You have to multiply by 3.
Yeah, I got to take whatever this number is and plug it into as my x, which is multiplying by 3. So 3 times 0 is what?
0.
3 times 1 is what?
3.
3 times 2 is what?
6.
3 times 3 is what?
9.
3 times 4 is what?
12.
3 times 5 is what?
15.
3 times 6 is what?
18.
3 times 7 is what?
21.
3 times 8 is what?
24.
3 times 9 is what?
27.
Okay? Do I have my 10 entries? Can I make these into ordered pairs now?
Yes.
Yep. I'm gonna come over here and make them into ordered pairs. 0 and 0. Have my parentheses and my comma separating them. 1, 3, 2, 6, 3, 9, 4 and 12, 5 and 15, 6 and 18, 7 and 21, 8 and 24, 9 and 27. Now I can graph this. I can graph this. Pretty easy. I know that I'm going to come over here to this one right here. And after I make my function table 10 entries, I then, step 2, graph the ordered pairs. Okay? So I go 0, 0. See, that's why I start with that. It's real easy. 1 and 3, so I go over 1, up 3. Then I go over 2 and up 6, over 2, up 6. Then over 3 and up 9, over 3, up 9. Over 4, up 12, over 4, up 12. Over 5, up 15. And then over 5 and up 6, see, I can't, I run out of room. Okay, so I have the ordered pairs. I know what they are. But I'm just going to graph the line. So I'm going to take my ruler now, and I'm going to connect it. The way you know on these equations if you have it right is if they connect to make a straight line. If I had a point way, like if this point at 4 was way down here, I knew it wouldn't be right. If there was one way up here, I knew it wouldn't be right. Okay, when I was graphing these, when I was learning, my math teacher used to tell me, if we're graphing this line, you have a W and not a straight line, you're probably not doing it right. If you were having points all going in and out. So it's a straight line, we know it's right. Okay? Now, I'm going to get into a harder equation now. A harder one. I'm going to come over here. Okay? Put this graph over here. I'm going to make a new table. And my equation is going to be y equals 2x plus 4. X, y, and I'm going to make my 10 entries like before. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. This one is not going to go through the 0, 0. Guess why? What happens if I put a 0 into my x? What's my answer going to be? Rachel? 4. 2 times 0 is 0 plus 4 is 4. What's my 1 going to be then? 1 times 2 plus 4. Marco? 6. Now I'm going to plug my 2 into there. 2 times 2 plus 4. What's 2 times 2 plus 4? 8. 3 times 2 plus 4. What is it? 10, because 3 times 2 is 6 plus 4 is 10. Looks like we have a pattern coming, huh? Look at the pattern. What's my 4 going to be? Eli? 12. 2 times 4 is 8 plus 4 is 12. What's my 5 going to be? 14. Okay? 2 times 2 times 5 is 10, plus 4 is 14. What's my 6 going to be?
16.
16. 6 times 2 is 12, plus 4 is 14. What's my 7 going to be?
18.
18. 7 times 2 is 14, plus 4 is 18. Dominic, what's my 8 going to be? 20. 2 times 8 is 16, plus 4 is 20. And 22. 2 times 9 is 18, plus 4 is 22. Now, still not quite done yet. I got to graph these now. Actually, I'm going to make them into ordered pairs. 0 and 4, 1 and 6, 2 and 8, 3 and 10, 4 and 12, 5 and 14, 6 and 16, 7 and 18, 8 and 20, 9 and 22. I know the ordered pairs because I split them up with commas and I put them in parentheses. Now, guess what? Some of these get too high. I'm not going to be able to graph all of them. But I start at 0, and my 0 is 4 high. So 0 and then up 4 goes right there. 1 is 6. So I go over to 1 and up to 6. Over to 2 and up to 8. Over to 3 and up to 10. Over to 4 and up to 12. Over to 5 and up to 14. Over to 6 and up to 16. And guess what? I ran out of room. So I'm going to then connect the lines, on the points on my graph to make a line. Bam. Just like that. Bam. Okay. Now, I'm going to show 2 more kinds of graphs that you're going to see in your work and your homework, okay?
Every time you're graphing like that, is it always just going straight up?
It could go down. Now, what would happen is, if it were a -2 times the x, then it would come down. Because what would happen is as the numbers got bigger here, since we're multiplying it by a negative, these numbers would get smaller. But since we're multiplying a positive number by other positive numbers, it's going to go up. Now, watch this graph though. I'm not going to make an ordered pair. I'm not going to make a table with 10 this time. I'm only going to make it with like 5 or 6. You'll get the point. X equals 10. Okay? X equals 10. X and Y. Guess what? X is always going to equal 10. But my Y, I'm going to change my Y this time. Let's see what my Y is. If Y is 0, X equals 10. Y is 1, X equals 10. Y is 2, X equals 10. Y is 3, X equals 10. Y is 4, Y is 5, X is always going to equal 10. Guess what? So I'm going to come over and graph it. X is going to equal 10. So every point, X is 10. I don't even have to make a function table. I can just use the graph. So no matter how high I go, X is always 10, isn't it? That's a vertical line. Goes straight up and down. Doesn't slope, straight up and down, because X always equals 10. Okay, this is X equals 10. What if I have that Y equals 10? How am I going to do Y equals 10? If I have 0 and Y equals 10, how high do I have to go up? Alec? Nope. Y always equals 10. Y always equals 10. So no matter what I have for X, Y always equals 10. That is a horizontal line. Okay? So when you have an X equals or a Y equals, that's just a number. That's easy. We know it's either going to be a vertical line if X equals something, or a horizontal line if Y equals something. Okay? So when you're going to start your work, you're going to make 7 graphs. Okay? On your binder paper, you are going to make the function table. Okay? With 10 entries. Then you're going to turn that into graphs. Okay?